In this Golang tutorial / project, we will be building a reusable command module for managing multiple commands within the same command line application. This project is rated beginner to novice. Basic understanding of Git and Golang syntax is expected, but specific features relevant to this project will be explained to the best of my abilities. Speaking of which, in this project you will learn / practice creating new modules in Go, creating and managing multiple packages, using interfaces and struct embedding, using the flag package to parse arguments, and adding color using ANSI escape codes. With that being said, let's get into the code. Here we are in VS Code, my editor of choice. Let's go ahead and create our first file. I'm going to call this main.go. I'm going to save that here in the root directory. Package main, func main, and for now we're just going to print fmt dot println hello world. Now I am using the Go extension here in VS Code, so I'm going to come down here to the bottom and select our Go version. I'm going to choose the latest Go version I have installed, which is 1.23.0, but you can choose, well, whatever version you want. This tutorial was not going to require any particularly new version. Let's go ahead and create a new terminal. I also like to move this up into the editor area. Just makes this a little bit easier to work with. Just going to pin it. Close the welcome page. We can go here, we can go run main.go, and everything works perfectly great. Next, we're going to create ourselves a README file. It's always good to do this a little bit early. I'm going to use Markdown, and we're just going to call this Go commands. We can obviously change this later. It's just good to have it already. And with that, we're going to come over to our terminal, and we're going to create a new Git repo. So git init, and git commit. Sorry, git add first, add our files. See, that would be our main file and our README file. And then git commit -m, and we call this first commit. There we go. We're all set up and ready to go. To begin, let's come over here and create a new folder called command. And inside, we're going to create a new file called command.go. This is going to be getting our command package. We're going to define a new type called command, and this is going to be a type interface. Now, basically, an interface is a series of function definitions. We're not actually implementing anything. We're basically saying any object that follows these series of definitions is considered a command. In our case, that means anything is a command is it has the getName function, which will return a string. We want a function called printUsage. And we're going to want a function called run, and that will return an error. Coming back over into main, I'm going to come up here, I'm going to create a new variable, I'm going to call it commands. This is going to be a type of slice of command, command.command. Now this is going to throw an error because it doesn't actually know what it is. This is because our command, of course, is in a different package. So to be able to tell Go where this package is, we need to create a new file called go.mod. Then create our module, and then this is where you put your module name. If you're going to push this to like a public repo and you want people to be able to download it, you usually do something like github.com/binary soup / bloody blah, whatever the module name is called. But if you're just going to keep it locally, you can honestly just call anything. I would just seriously just call it local. And then also helps to define your Go version in here. For me, it's 1.23, but again, use any version you wish to use. And we can go back into main, and we can come up here. We can expand this import into a multi-line variant, which looks like this. And we're going to include we're going to include local, our module name, /command. And there we go. Now it's going to complain that this isn't actually being used because, well, it's not. But we're not done with quite yet because we want to initialize it to an empty array, which looks just like that. Next, we're going to come down here into main, and we want to grab our command name from the arguments, which we can get from os.args. Now, for os.args, index 0 is going to be the name of this program that we're running, and the first parameter, the one we care about, is going to be index 1. So what we want to check is if the length of our arguments is less than 2, then we don't have enough arguments to work with, so we can just do something like log.fatal. Log is just going to print something to the command like fmt, but it's also going to print, I think, a timestamp, and fatal just means terminate the program after you do this. So log.fatal, and say not enough arguments. If we do have enough arguments, then we're just going to do fmt.println, and we're going to print os.args at 1. In fact, actually, this makes it a bit fancier. We can do printf, and we can use a format here. So you can say command, and then we'll do some quotes, %s, and quote n/n, and that'll look a little bit better. Go back to our bash program, and we're going to run that one more time. So we do go run main.go. We should get an error, not enough arguments, because we did not provide any arguments, but now we add a command, call it foo. Look, there we go, command foo. Now once we actually have our command, we actually want to be able to run it. So we want to search our command list for a command that has, remember, our command has a function called getName. We want to check for the command that has the name that we provided. So I'm going to do a little helper function here. We're going to call it func_run command. It's going to take in the name as a string, and it's going to turn an error. It's going to say for, and say command in range. This is how you do a for each loop in Go commands. Now the first parameter is actually going to be an int, which means it's the index. We don't care about the index, so we're just going to put an underscore to say we don't care, and we'll get the second value, which is the actual command. And we're going to say if command.getName is equal to name, then we want to return command.run. Remember, run returns an error, so we're just going to proxy it up the function. And then at the bottom, if we cannot find the function, we're going to need to return something. So we can use fmt, and there's a handy function in here called errorf, which is the same as printf, but it works, returns the value in form of an error as opposed to printing it to the screen. So the format, we're going to say unknown command, and we'll do the same format we did here. Since this is an error, we don't want to put a /n there. And we're going to say name, just like that. Now instead of this, we can remove both these lines for now. And we can simply just say run command, and we want to pass in this value. Now, of course, we need to check for the errors, so we'll do that as well. Now what we can do is we can just say simply if error does not equal nil, and then handle error case in here. There is another way to do this in Go. If you were to do this, you can say if error is equal to this, semicolon. This is probably the only use case you'll ever see semicolons in Go. And we can say if error does not equal nil. And this basically just combines the two into one line. I don't like doing this all of the time, but this is one instance where I think it's all right. And if there's an error, we can just simply do, log.fatal again and just print out the error like such. Let's run it again. If we provide nothing, it'll just tell us not enough arguments. Provide foo, it should tell us unknown command foo, because our command list is actually empty. That seems like a good amount of steps, so we're going to come over to our Git repo, check our status. Added a few things here, so I'm going to get add dot. I'm going to say git commit -m create command package. Sweet. Now let's create our first command. So we're going to come over to the command struct, and we're going to create a function. No, we're going to create a new type called command base. And this is going to be a type struct. This is going to be the base struct for all our commands. Now we're going to add a few members. We're going to have name of type string, and we're going to have description of type string. Now we want a command base to implement as many of these interface methods as it can. So any struct that extends from this base will have access to these methods. So we can go ahead and implement func command base. This is the receiver type. I'm going to implement the getName function. And here we're simply going to return command.name. Some idea for print usage. And here we're going to do a little bit of formatting, so we can do fmt.printf. And we're going to do %s, and we're going to use this little vertical line here, and then %s again, /n. The first part, we're going to use the command's name. And the second part, we're going to use the command's description. Next, to make this a little bit easier to use, we're going to create a creation function. Go doesn't have constructors like other languages, but we can just create our own pseudo constructor just by using a global function in the package. So name string and description string. These are our inputs. And this is going to return a new command base. And here we can simply do return command base. And we can just pass along the parameters as such. Next, when you come over to command, I'm going to create a new folder called sample. This is going to store some of our sample commands you can use to get an idea of how this package works. So I'm going to create one called hello. And this command is basically just going to print hello world to terminal like we did before, but this time in the form of a command. It's going to create a new type called hello command. And it's going to be of type struct, and it's going to extend command dot command base. And there we go, it imported local /command. Now this isn't technically quote unquote an inheritance, this is what you would call composition, but when you don't give a name here, you just provide the type. This is basically saying Go that this type like explicitly includes it, and any function in command base is automatically available through this type as well. And I'm going to do something similar that we did down here with the creation function, so we're just going to, let's not copy that, let's create it from scratch. You'll see why in a second, because this one doesn't actually need any parameters. You're going to return a hello command. And what we want to do here is return new hello command, but for command base, which you can just say like that. We can use the command's creation function, so command.new command base, and pass a name and a string. We're just going to hard code this here because this isn't going to change per instance. So the name of the command is going to be hello. In description, we're going to say prints hello world to the console. Like such. Now we can go back into main, and inside this array here, we're going to add sample dot new hello command, like such. And there we go. Now this is going to throw an error because our sample command does not implement the command interface. It's missing a function. Remember, our command base only implements get name and print usage. It does not implement run because there's no like base functionality for what run should do. So we're going to have to implement this over here in hello. So func command hello command run, and it returns an error. Of course, this is our hello command, so we're just going to print again fmt.println hello world. And then this needs to return an error, so it's going to return nil for no error. And go back into main, we'll see that error is being cleared up. And we're actually ready to run the hello command. So we can go in here, we can go run. Go instead of we're going to pass in the command hello. And there we go, hello world. Main was able to find the command that matched their name, which we defined right here, and is able to run the hello command and handle any errors. In this case, nothing happened because it's very simple. But there you go, that is our first command. Let's go ahead and create a commit of that. So git add dot git commit -m add hello command. Now main file is getting a little messy here. Now this is a very small file by programming standards, but our main files we want to be very clean. We want to do as little as possible. In this case, it's handling, well, the amount of args is the kind of thing you should handle in main, but like this run command function and looking for commands and finding it and storing the commands themselves, this is not kind of thing we want main to do. So we're going to create a new file. We're going to come into command and create something called a runner. This is going to be a we're going to define package command because we're still in the command package, and then create a new type called runner. It's going to be our command runner. It's going to be a struct, and in it we're going to store what we did before, a slice of command dot commands. Well, command, that's the type, but there's multiple of them, so we got commands. I'm going to create the pseudo constructor we've been doing so far, so new runner. So it's going to return a runner. You want to pass in commands. So I'm going to say commands. Now we could pass in a slice of command like we did up here, like such. And this would work, but since we're using a function here, we can use something a little bit fancier and go, this is syntax called, I believe it's pronounced Veridic or something. Basically the idea is we can do return runner, and we can set commands equal to commands. Now, although this isn't defined as a slice, you can treat it as a slice type. And what we can do on the other side, now we got an error here, select dependency, yes. We are still in the command package. We don't need to import command.command. That was my bad. I think should be fine. Sweet. Okay, over into main. We're going to create a new runner here. So we're going to say runner equals command dot new runner. Now we don't actually have to pass in an array here. What we can do is we can just pass in the command like such. And the way this works is basically you can put as many numbers parameters as you want. Like 1, 2, 3, 4. Getting my commas in the wrong place, but get the idea, right? And basically all of these will be combined into a single array that's just then available here. It's just a very more convenient way to create or to handle array parameters, if it makes sense. Instead of using run command here, what we want to do is we want to move this run command into the other class that we just made. We need to change its receiver type to be a runner. We need to change this from lowercase to uppercase, which means this is going to be publicly available on this object. And we're going to use r.commands, because that's where they're stored now. Like such. Back in main, we can simply just call runner, not run commands, and everything works. Everything works just the same. Now, of course, we don't need this thing up here anymore because now we're constructing that here in main as we pass it to the runner. And now main is a lot cleaner. Now you may notice we're using an array to store our commands, and then we're looping through it in linear time and checking the names. This is fine when we don't have a lot of commands, and this would probably always be fine. But there is a slightly better data structure that would work for this type of problem, and that is a map. So a map will map a string to a command. So up in here, we're going to have to create our commands map. So we can say commands, the map of type string and command. And we do that to define an empty map. Now we're going to basically copy this array. We're going to copy this loop. I'm going to change this to just commands because we're going to get from the parameters now. And we're going to say commands at command.getName is equal to command. And then we're going to pass commands in like that. And now down here, what we can do is we can say command and then OK is equal to r.commands at name. Now we can look up a command by its name directly. It will return the command, and OK basically is a boolean to say if it was actually found in the map or not. So if it was not found, so if not OK. And we want to return our not found error. If it was found, we simply return command.run. And there you go, everything will still look exactly the same, but this is a slightly better solution. Next, it would be nice to know what kind of commands we have available to us. So we're going to create a new function called list commands. This is simply going to print all our commands to the terminal. So we're going to do the same loop we did before. It's going to do r.commands. Now in this case, if we were to use this first parameter, this would be a string. So we're using like the key and the value, supposed to be index and the value, but we just don't care about the key. We only care about its value. And then we're simply going to run command.printUsage. Now in main, we're going to use what's called the flag. So this is like the command line flags that you would pass to the program to tell it what kind of like special like configuration you want it to do for this run. So in this case, we're going to define a flag called ls, which is a common, I guess I can show you, which is a common terminal command on Linux, or Bash at least. That just prints everything that's in the current directory. So I thought ls is just a nice keyword to say list all our commands. So ls is equal to, is going to be the flag package, and we want to use the function string. So it's going to find a new, sorry, I want to use this value bool. It's going to find a new bool flag. We get a few parameters. So the name of the flag is ls. The default value is going to be false. And what's its usage? List all commands. Now I often forget this like a lot, and make sure you do this. You have to run flag.parse. If you don't run this, then the flags will never be parsed, and you'll be wondering why none of your flags are working. This is probably why. Now ls is actually going to be not a boolean, it's going to be a pointer to a boolean. Don't worry too much about that. It just means when you have to dereference it, you have to use star ls as opposed to just ls. Now we can add a little if statement. So if star ls, so if the else flag is turned on, then we want to do runner dot print, dot list commands. Now this is going to throw an error because our runner action hasn't been created yet. We need to move this down a little bit farther to here. And then if this is true, it's going to return, say, okay, list commands, and just exit the program. Let's come back over to a bash terminal. We're going to do run, well, not run hello, we want to do run.ls, and there we go. Prints error. Little thingy, hello is our name, and this is the description we passed in. Remember, we implemented print usage on command base, and it looks like this. Now, common kind of courtesy to do when making console applications is instead of filling like, a kind of an aggressive not enough arguments error is actually just to print the usage if you don't pass in enough arguments. So what we can do here is we can simply say if the ls flag is present or there's not enough arguments, then we want to list the commands. Of course, we need to move the run up a little bit more, which is fine. Like such. And now, if we were to run with ls, everything should work the same. But if we don't pass any arguments in, we also get the same functionality. It seems like a good amount of work for now. So git status. We can see we added the main file and we added the command runner. Or sorry, we changed the main file. We added the command runner. So git add dot and git commit -m create command runner. Now our command's looking pretty good. We can run the hello command that brings hello world, but that's kind of boring, right? Maybe you wanted to change the name of who we're saying hello to. Well, this is what we would need arguments. Of course, hello itself is an argument to the main program, as is ls, when we run the command like that. But what if we want to pass arguments to the command hello? Well, we can do something very similar that we did with flag in main. If you come over into command, we're going to add a new member to the command base. We're going to call it flags. And this is going to be of type flag dot. We're going to use flag set. This actually needs to be a pointer. And down in here, when we do the construction, we say flags, and we're going to use new flag set. I mean, a name for the flag set. I don't think this actually matters what it is, so I'm just going to use the name of the command. And the error handling function, I'm going to use flag dot exit on error. Now, what flag set is basically it's exactly what flag is. Except flag here works like just on the flag package, like outer layer, it works with os.args. But a flag set allows you to provide your own args to work with, which is exactly what we're looking for. So we can come over to hello and in run here, we can say command dot, and we have access to flags because remember hello command extends from command base. And we can say same thing as before. See, we get all the same functions as we did with just the basic flag package. So we're going to define flags.string. It's going to be a string flag this time. So the name is going to be, well, we're just going to call it name. Its value, we're going to use world as the default value. And usage, name to use when saying hello. Because we're going to need to get its value. This is going to be a pointer to string, which again, just means you need to dereference it. And don't forget, command.flags.parse. Otherwise, nothing will happen. Now, see, this is not just an empty function. This one actually wants you to pass the arguments in. Now, we don't have the arguments, which means we're going to be able to receive them. So args slice of string, and I'm going to pass args in like that. In here, print ln, we're going to change this to print f. I'm going to say hello %s /n, and I'm going to pass in star name. Now go over the main, it's going to be throwing a new error because we changed our run interface. It no longer implements the command interface, so we can no longer use it as a command. So we're going to come over here into command base, and we're going to need to change the run definition to accept args, so slice of string. Now this is going to throw an error in run command because it wants args. It doesn't have them, so we have to add them here as well. Just need to go through all the levels of the chain and fix the errors as we go. And that's what it's going to be here in main. Now what we're going to do here is we're going to pass in os.args at 2:. So what this is going to mean in Go, this is a slice, which means we're going to start at index 2, and we're going to take that index and everything that follows it. Remember, index 0 is the name of this program. Index 1 is the first primary pass in, which is our command, and then our args will be everything that follows it. And that is everything we need. So we can go up here, we can go run main hello. This is going to just print. Looks my file didn't save there. We can just run this and print hello, and it just prints hello world because world is our default value. But we can say hello to, oops, I already need that. We can say hello to -name Bob. And there we go, hello Bob. And now we can pass arguments to our commands. So back to bash, we're going to git add dot get commit -m add command args support. Now another really useful advantage of using the flag package is it gives us access to a default flag. So I'm going to run just main.go, and we can use the -h flag. Now, this is provided for free to use when you use this package, and this is basically like the help flag. So since we're using go run main, our name for our executable is just some temp file. Don't worry about that. But you can see that we have -ls flag, and it lists all commands. If we were to run the same thing on hello, as you can see, usage of hello, -name string, name to use when saying hello, the default is world. Now this is alright, I suppose, but I would like a little more control over how this usage looks. For this, we can go into command, and we need to do a little bit fancy stuff here. We're going to need to change this not into return, but into a variable, which we will return down here. And we do this because we need to do a little bit extra work here. So we can say command.flags, and we need to define the value called usage. Now usage is a function, or I guess you call it a function pointer. So we need to set it equal to a function. And this function basically is just the function that's called when you use the -h flag or request its usage. So for this, we're going to use command.print usage. I want to add a little bit extra text here. So I'm going to say fmt.println. I'm going to say these are our options. And then we're going to use command.flags.print default. So this is like the default print for usage. But we're going to print the command usage first, then the options, and then the defaults. Let's see what that looks like. There you go. I keep forgetting to save my files. Yeah, here's our command string, or here's our command usage. Hello prints hello world to console, and then our options are name string, name to use when saying hello. And that looks a lot better. Let's create a quick commit of that. So git add dot and git commit -m implement custom usage function. Now our code is looking pretty good. We can create custom commands, we can provide custom parameters. Everything looks good, but to be honest, it looks a little bit bland. Since if we pass any unknown command or command, it's called unknown. Unknown command, unknown. This is an error, but it doesn't really stand out as an error, does it? I want to add a little bit of color to make this pop. Now, color in terminals is possible. In fact, you're seeing it right now after all. It's a little bit tricky, so try to stay with me for a little bit. it will get a little bit complicated for a bit, but then it's going to get a lot simpler. Now down in the description, I'm going to link this resource. This is a GitHub gist that basically describes what are called ANSI escape sequences. Again, this is going to look like a lot of weird lingo and whatnot, but basically what it is it's this little escape sequence that just tells it how to style what follows it. For example, here, use this little character here. This is just the escape sequence that says what follows is not to be interpreted as text, but interpreted as configuration. And then you provide some things. So 1, in this case, means bold. 31 means red foreground. And M means basically like end configuration. And there's a lot of different things in here. Again, I'll link this resource down below if you want to look for it yourself. But what we really care about is some of these things. Bold mode, dim faint mode, underline mode. Not all of these are supporting all terminals. Like I don't think my terminal supports italic, but don't quote me on that. And you have all these colors: black, red, green, yellow, blue, magenta, cyan, white, and then default, which resets color code, and reset, which just resets everything. So I'm going to show you how this works. So this is a lot easier to see in practice than to read this resource. I'm going to come over to a hello command, and I want to add a little bit of color to this. I want our name to print in a different color. Say let's print it in a bold green. What we can do is we can type \x1 capital B. This is like the escape sequence. This is what VS Code says it is. Don't know what that means, but that's not important. Then you want in left bracket. Bold is 1 and green is 32. And then M says end. And on the other side, we do the same thing again. \x1 B. And I'm going to say open bracket 0 means reset all, and then M to end it off. Now if we come into here, hello foo in bold green. That looks pretty good. It matches or clashes with this. Let's change it to a different color, maybe yellow perhaps. I believe yellow is the next number, 33. Let's find out. And there we go. Yeah, bold yellow. And just like that, looks pretty good. Now we can add these little configurations all over our code, but this doesn't look very good, right? This is really hard to read. So what we're going to do is we're going to create a new package in the root directory. We're going to call it style. Of course, we're going to create a new file, call it style.go. And define the package, you guessed it, style. Now we're going to do something that's pretty unique to Go. We're going to create a new type called style. And this isn't going to be an interface. This isn't going to be a struct. This is going to be a slice of string. Because in Go, a type can be, well, just about anything. In this case, we want a slice of strings. We're going to create a new function, so we're going to call it func new. We could call this new style, but I'm just going to call it new. You'll see why in a second. And we've got our mods. And we're going to use the verdict function syntax again to call it of type string. This is going to return a new style. And remember, the verdict function syntax allows you to treat the variable as a slice. So this will be a slice of strings. Style is a slice of strings, so we can just return mod. Now I'm just going to copy and paste in a bunch of constants. So feel free to pause the video if you're following along to add these yourselves. But basically, this is just what we described from the resource. So 1 means bold, 2 means dim, 4 underline, and then black, red, yellow, blah, 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 all the way up to white. And I guess if we so wish, we can also write reset is equal to 0. Now I'm going to create a new function called, we're going to use style. I'm going to call this function format. And it's going to take in a string. We're just going to call this S. That's why I have this style. It's like STY because S for style gets confusing for S for string. I think this just makes a little bit more sense, and this returns a string. And basically what this is going to do is it's going to take in a plain text string, and it's going to style it based on the format that was described by the style. What does that look like in practice? Well, first of all, we have a little edge case. If your style is empty, remember it's a slice of strings. So if there are no modifications on the style, we basically just want to return the string as is. So we're going to create a little helper function for that. So func style. I'm going to call this is empty. And it's going to turn a simple Boolean. It's going to return length of style. Remember, style is an array. Is equal to 0. So the array style is empty if there are no elements in its, well, in itself. So you're going to say if style or sty dot is empty, then we simply want to return s. If it's not empty, then we're going to do what we did over here in hello. So I'm just going to copy this text here to make it a little bit easier. Now you want to return. We're going to use fmt. We're going to use printf. You want, there's a thing called sprintf, which basically is the same thing as printf, but returns the value as a string. So you want to copy this x1b like such. And then we're going to do %s, m to end it off, %s again. And then we're going to add the closing thing here. Now this is where we could put the %s for reset. I'm just going to put 0 here. And be honest, I don't think I want to put reset up here after all. And for our two values here, we got 2. For the first value, we have, this is going to be our modifier. So we're going to use a helper function in the strings library. So strings.join. I'm going to join all the elements in our style with a semicolon. And for the second, we're just going to add our string. Now this looks kind of complicated and all over the place, but this is actually all we need to do this. So we can go back over into hello, and what we can do here is we can go style. This is our package dot new. And we're going to say we want it to be style dot bold and style dot yellow. And these are our constants we defined. And then we can say format, and we'll pass in our name. And this accomplishes exactly the same thing. Let's clear all this stuff out. This accomplishes exactly the same thing as we have before. So we go back into bash, we run it again, and there we go, bold yellow. And this is magnitudes easier to read. We can see, oh, we're creating a new style. This style is bold and it's yellow. And using this style, we can format it. We can even come up here and we can say, creating a style like this, or we can maybe even call it bold yellow. And we can say bold yellow.format name. And we're saying we're formatting name in the style bold yellow. And this is just a very clean, very effective way of doing this. Another thing I like to do is to come back into style. I'm going to create a new function and call it, not function, new file. I'm going to call it palette. This is where we can find a bunch of style constants, basically. So what we can say is, for example, in main, I would like our error to look a lot better than this. So I'm going to create something called var and call it bold error. And we can say is new. Remember, in the style package, you don't have to say style every time. And it's going to be bold, and it's going to be red. And now we can take this into main, and we can change it to something else. I'm going to say fmt.printf. Or now let's do the C. Actually, just straight up go style dot bold error dot. We can print import via style package there. That format. And we can format. It'll be all caps error. And of course, this just returns a string. That's no good for us. So we can come back in the style. And we can create some of our helper functions. For instance, we can create our own print function. So you can say println as string. And this is just simply going to do fmt.println. And we're going to say style.format s. We create the style format string and we just pass it to print line. Of course, we can just do this on the other side, but I like doing it like this because it's a little bit easier to read. So what we have to do is style.bolderror.println. Now it's going to print this line using the bold error style. And as for the rest of it, we're just going to do fmt.print ln. Oh, sorry, this should be print. We don't want print line here because we don't want these to print on different lines. So let's go back into style again, and we'll add another helper function, which basically does exactly the same thing, except using printf. Instead of using println, it uses just print. And fmt to println, we're just going to print error. Now if we go into bash and we try to pass a command that doesn't exist, big bold error, error, unknown command, foo. And that just looks a lot nicer. Another place would be nice to have some color would be here in a usage commands. So I'm going to come over into command and we're going to change our print usage. So we're going to say printf, same old, but here we're going to change this to, let's say style dot new. I'm going to do style. Let's say let's print it in cyan. Dot format. And I'm going to pass in the command name. Description we'll leave as is, but inside the usage up here, I think I'm going to print this in something different. It's going to say not as FMT. I'm going to say style dot new. I'm going to print this in magenta. And now we can back in the bash, and we can run this. Now it prints hello in cyan. Quite nice. We could make that bold, but yeah, let's make that bold. Why not? Of course, feel free to play around with this yourself. Making something your own is one of the best ways to learn. So you want to say style.bold. Run that again. Now it's bold. And now we say hello-h. You can see we get a bold cyan, prints hello to the console, and we got a purple magenta, not bold, and it prints the rest of it. And that just looks way, way better. Now you might be wondering why we don't just add, the bold cyan and the magenta to the palette. Now the palette, at least this palette inside the style package, should remain pretty consistent, I would say. And what I mean by that is errors are pretty standardized red. Successes would be green, maybe warnings would be yellow. But in terms of printing, commands in cyan and options in magenta, that's a very application specific, very user specific. And therefore, I don't think it makes sense to kind of put this type of thing in palette. Of course, you could also define your own palette file outside the style package in whatever application you're making. That would be a good place to do it. But I wouldn't recommend just adding every single new style into palette, because if it gets super bloated, then, well, it's not really a very useful file anymore, is it? So that sounds like a good place to commit for now. So we're going to say git add dot git commit -m create style package. It's a bit of a bonus fact. I guess I can talk about why these colors are the way they are. Like red, green, yellow makes sense. Or sorry, I should say red, green, blue makes sense, and yellow makes sense. But magenta and cyan, why these colors evolve colors? In fact, why do computers use red, green, and blue as their primary colors when kindergarten taught us that the primary colors are red, yellow, and blue? Well, basically the way it works is paint, or substances like paint, use what's called a subtractive color space. Think about mixing all colors paint together. What color do you get? You get black. Light, on the other hand, like the light that's emitted from your screen, uses an additive color space. That's why mixing all colors of light together gives you white. So in a subtractive color space, the primary colors are red, yellow, and blue, with secondary colors being orange, green, and purple. But in an additive color space, the primary colors are red, green, and blue, with secondary colors yellow, cyan, and magenta. Now, of course, it is possible to create colors other than just V6 using RGB. I mean, look at your screen right now. But these are just the single bit values, right? So full red channel gets you red, full green channel green, full green channel blue, full red, full green gets you yellow, full red, full blue, magenta, full red, full green, cyan. Just thought that was kind of a cool fact. And that is just about everything for this command interface. I really like this thing. I think it works really well. It's super clean, it's super usable. We saw how easy it was to create new commands, how customizable it is with colors, how modular it is. Hello command, all its implementation is all completely in its own file, its own complete logic that nothing else has access to, because nothing needs to know how this works. All main has to do is, well, nothing. All main has to do is pass the hello command to the runner. All runner has to do is just check its name against its commands and just calls run. It doesn't care what it does. All it cares about, if it prints an error, then it will return an error. And main only cares if its command returns an error, then I'll print the error. It doesn't actually care what it does because that's not its job. I think I already mentioned this once, but I would really recommend trying to make this project your own and change up the styling a bit, use different colors. Something interesting you could do inside runner, you could keep track of how many times each command is run. And then you could save that to a file after running the command and load it every time you call this function. That could be a cool, interesting project. Either way, this code here will be available on GitHub, and you can just download it as a Go module. As for me, I'm just going to add some documentation, beef up the palettes a little bit, add some more helpers to style probably. And that stuff, nothing particularly interesting and worth showing on screen. But yeah, thanks for watching. Good luck in your projects. Stay curious, and happy coding.